everyone. We're here at the SPS, and again, now we're going to go over to the Umati booth behind me. This is going to be, we'll be taking a look at how companion specifications can be used or put to use in real-world situations. So I'll be meeting with here with Andreas Fath. Hey, Andreas.
Hi, Derek.
Hey.
How are you?
Very good, thanks. So Andreas Fath is in, he looks after the machine information interoperability. He heads that up for VDMA. And he'll give us a bit of a walkthrough to give you an idea of how you actually use what Umati does and how it marries that with the companion specifications. So in the end, you're getting value out of OPC UA with your equipment. So yeah, Andreas, walk us through it. What are the use cases? How does this work?
So at first, Umati Universal Machine Technology Interface is a community and initiative to bridge the gap between theoretical OPC UA companion specification development and real implementation.
Right.
So basically, for the machinery industry, it's a couple of use cases that can be fulfilled by the real usage of OPC UA companion specifications.
Okay.
From asset management to traceability, up to really production control monitoring, or even the product carbon footprint.
Oh wow, okay. So basically, whether you're trying to work with the low-level optimization of what your machine does, or enterprise-wide when you're looking at how you're managing your footprint for the overall operation, it sort of helps at every level.
Exactly, but the main focus is really on having real production information standardized over OPC UA companion specifications.
Right.
This is what we are doing also, let's say, under VDMA umbrella, together with partners like OPC Foundation.
Perfect.
And Umati exactly is taking these specifications and does, for example, demonstrations, events where companies can exchange what they learned.
So like the recipes for how to actually get this done.
Exactly. So it's really about getting it done in the industry. It's not about theory. It's really about
putting it into practice.
Do it, right? So, and these exactly are our special use case. There are much more. And the beauty is that today we have really so many companion specifications already released.
Right.
And this is kind of almost covering the whole shop floor.
Yeah.
So from robotics over plastic and rubber machinery up to also mining equipment, for example.
Right.
We have really a lot of specifications already developed. And now it's pretty clear that these specifications also have some use cases or, let's say, information in common.
Sure.
And this is what we do in our harmonization approach.
Okay.
And this is called OPC UA for machinery. So basically, OPC UA for machinery, from my perspective, is the specification where the industry is starting with, because there's like identification, finding the machine in a server, so get a great overview of all the machines, all the components, or having the machine states, process values, even energy management is right now in development. Okay. So OPC UA for machinery is the basis specification, where we have the general information for the whole machinery industry. Sure. And from there, we have the extensions that are more branch
specialized,
or machine specific. Exactly.
Right. Okay.
So, for example, if we take as an example a laser machine, for example.
Sure. Okay.
This laser machine is starting with a machine identification.
Right.
Then it has machine states.
Okay.
So you can identify the laser. You can have standardized information about the state of the laser.
Okay. Okay.
But then you still don't know that's pretty much a laser, because you just have an identification and a state. So you go on with a machine tool specification, because a laser is also kind of a machine tool. It's not drilling, but it's having a laser in the end, where normally the drilling equipment
drill bit would
a laser,
be, or
there's a laser. So
and it has a different behavior than
exactly. So there comes the machine tool specification,
Makes
and
sense.
then there comes the laser specification. Right. So it's really modular.
Kind of a logical progression to the semantic model.
Exactly.
Yeah, yeah.
So it's really modular, and it's building up from the more general information always to more specialized information for more specialized equipment.
Okay.
So you can basically figure out how to model almost every kind of machine that is typically on the shop floor. And this is really something where also our over 700 or maybe already 800 companies that are involved in this development are really kind of proud of, because they put really much effort in talking together what are the right information they put into the companion specification, how they name these information, how they describe the information, which data types they have. So it's really a long year approach.
Right, okay.
And especially for the implementation, umati is gathering the community of about 350 companies right now that already have joined forces to really do the implementation.
Oh, fantastic, right.
And
Matrikon is actually one of those.
Of course, of course. And it's really important, for example, to have Matrikon, because those companies are, let's say, the enablers, you know? If we don't have companies like Matrikon, it would be really tough for the industry to do the implementation. And also, for example, to do the implementation cost efficient and quick. Because of course OPC UA is open source, so in theory, everyone can do it by its own, but they have to have the knowledge, they have to have the time, and they have to have the will to do it. So a product that helps to do implementation is really important for the whole community and for the whole success of OPC UA, and especially companion specifications.
And I think that actually makes sense, you know, I think two ways, because I mean, this was a great overview, by the way, of just how the different specifications overlap with each other. I think another thing, maybe you can touch a little bit on it. I mean, not everybody will have it implemented directly in their device, but they may want their device to take part in being able to be part of that information structure. So for us, one thing that was interesting is we can facilitate building a machine or device that actually does it, or if you don't have that implemented in it yet, but you would want it to be supported to represent this information, we can dynamically load companion specifications, so even end users, if they really needed to, they could bring in the data and still follow this type of recipe to say, okay, our older equipment that doesn't have it yet could actually be part of the fold to do this.
This is, I believe,
two paths, right?
Exactly. I think this is why Matrikon is partner of umati, right? Because you're a player in this whole ecosystem that makes it more successful, more easy, and more, let's say, also usable for retrofit, for example.
Exactly. The more approachable for end users who just want to use it, do a PhD study on it.
Correct. And one example, for example, how we did it.
And an example.
Our demonstration. So we have this weighing system demonstration. And this is for the use case, basically plug and play. So in the end, we have here 3 weighing systems that easily can be just unplugged and then plug again another weighing system, for example with Siemens or Meta Toledo. So I can unplug the Siemens weighing system, so the whole system is down, and then I just plug, for example, the Meta Toledo system, and the system is directly up again.
True plug and produce or plug and play, as they say.
Because all of them have implemented the identification part of the machinery and the weighing system companion specification. So they have an identical
the system recognizes the new component to say, you do the same thing, I'm going to use you now.
So we have to do the implementation once. Have to teach our small Raspberry Pi in here what interfaces will be there.
Are relevant, what it needs to use for the process.
And as all of the weighing systems are having the same interface implemented, it's just plug and play.
Fantastic.
Plug and produce.
So
it's really amazing, and it's really an easy example how the companion specifications are helping fueling the industry in this really interoperability, and also if something is breaking down, you can directly bring another one and just plug it and it's working. So downtime reducing, integration costs goes down. So it's really a driver for getting smart manufacturing and digital transformation.
Nice. Andres, thank you for that whirlwind tour of everything that you guys do. That's great. Great story, great purpose. So, you know, for us, Matrikon's tagline is powering interoperability. You guys, I think, are key in helping people actually get the most out of that. So thanks a lot. Pleasure
talking. Thank you for coming over.
And see you next time.
See you next time. Bye.
Thanks, guys.